In this tutorial, I am going to show you how you can generate ROC curves for a multi-class model. This is a notebook we'll use. It has the code we'll use, but let's look at how a typical ROC curve looks like. So this is how a typical ROC curve looks like for a multi-class model. So each of these curves here will represent a class. Okay, because it's multi-class, we normally use the one versus rest approach or one versus all approach or whatever you want to call it. So that's how we do it. So in addition to the ROC curves, you can also include the area under the curve value. So for each class, you can add the AUC value for that as well. So these are things you can decide to add just to add information for your model. So let's proceed. So back to the notebook here. So with this tutorial, you don't have to write your own codes. I have this notebook available on GitHub. So there's my GitHub repo where you can find the notebook. We are going to use this one here, the ROC Multiclass Random Forest. We are going to generate the plots for a random forest model. So to run the notebook, you just need your browser. So I'm already on my browser. So you can do same and then just visit Google Colab. I will leave the link to this page in the description box. So Google Colab allows you to run Python codes using your browser. It's a cool platform. So that's what we are going to do. So once you are on Google Colab, So once you are there, you need to visit this tab here, the GitHub tab. So click it, and then here you have to paste or enter the URL for the GitHub repo that you want to run the notebook from. So this is my repo. So just take a look at the link here. I will leave the link in the description box anyway. So use the link that you'll find in the description box and then just enter that here. So I am going to enter mine right now. Let me paste it here. So there's the link. So once you've pasted this link, just go to search. There's a button here. So just click it and then it will search for you, and then all the notebooks in that repo will be shown here. So scroll down. We are looking for the notebooks / ROC Multiclass Random Forest. This particular one here. So this notebook here. So this one here / means that this notebook is in a folder or directory. So just take note of this name. So once you have it, just click it or double click, and then Google Colab will open the notebook for you. So that's how it is. You may have some warning, but you can just ignore the warning and run the code. So that's fine. So that's what we are going to do. So here I've prepared the codes. I'll also give some explanation so that those who are beginners in the field of machine learning will have some understanding. So let's proceed. So in this tutorial here, I'm using a data set that was generated by authors of this paper. So you can just check it out. So the data is also on my GitHub repo here. I've uploaded it here in a CSV format. You can come to data, this folder here, and then you'll find the file there. So we are looking for this particular one here. So, and that's what you need. But you don't have to download it. We'll use the download link for this exercise. So back to the notebook. So ROC curves are used to evaluate machine learning models. And so that means that you have to first create your model and then feed it with data, and then after that you can evaluate using the ROC curves or ROC curves if you call it that way. So I will take you through how a typical machine learning process or activity looks like. So it's going to be very simple and then fun. So if you are going to do machine learning, you need to first get your libraries. We are using Python, so you need to have your Python libraries that you use. So for the start, these are the libraries we will use. And so with Google Colab, if you have the codes, all that you need to do is to just click this one here, this button here to run the code. So let's run this code together. So just click it, and then you may have this warning, but just click on run anyway just to run it. It's fine. So the code will be executed successfully for you. So if it's successful, you are going to see a green check here, a green tick here indicating that the code is successful. So let's proceed. Okay, so the code has been executed successfully for us, so we are ready to roll. Now, after getting your libraries, you need to also get your data. So here, I'm using the URL. Okay, I'm using the link to the file. So there's the file itself. It's on my GitHub repo. So I'm using the link or the download link for this file. That is what has been placed here. And so just run it. The link is valid. So just run it and then it will set the link for you. So now we are ready to read the data into a data frame. So with pandas, you can use the URL of a file, and that is what we are going to use here to get the data frame. So we have pandas here that we use. So just run it, and then you have the data frame being created for you. So we proceed. So with machine learning, one of the things you have to do when you get your data is to explore and then clean it. So exploration will help you to get information, which may even help you to determine what methods or approaches to use for the downstream analysis. So that is what we are going to do now. So let's proceed. So let's scroll down. So with the exploration, one of the things you definitely have to do is to check the shape. So for the shape, you are checking the number of samples and then the number of features. So rows and then columns, basically. So that's what we do. So this code here will return that information for us, and it's important we get that. For statistical purposes and reasons. So we have 2207, 34, meaning we have 2207 rows and then 34 columns. So there's an information we will need. So with pandas, you can also display some of the rows. And so that is what this code here does for us. So this will display the first 5 rows for us. So let's run this. That's also part of the exploration. Okay, so we have it here. So we have our rows here, and then we have the columns here with the column name. So sample ID, constant given, scroll, and then you find the other information there. So that's what you need to do. So let's proceed. So by the way, this data set is a malaria data set. So there's hematological data. So we have these measurements done. I've already covered a separate tutorial on this particular data for machine learning. So you can just watch that if you are interested. The link to that video is in the description box. You can also click the link right up there. So let's proceed. So I have the information here. So just to explore. So now with exploration, it's important to also get to know the column names. The columns you are dealing with. The names are important because you may use them later on for some queries. So let's list the columns here. Okay, so we have these columns here. That's in the data. That is what we have. So we are just looking at some of them, but we will just proceed. So let's proceed. So with the exploration, it's important to also get some basic information such as the column names, which you have done, data types, missing values, etc. So this code here, dataframe.info, will return some information for us. So let's run this code. You can also use Ctrl-Enter to run the code. Okay, so we have some information here. So we have the column names and the non-null counts here. So this telling you, it's basically the missing values. We are looking at information about missing values. But for this tutorial, our focus is to just generate the ROC curve. So I'll skip a lot of information here. When I say information, I mean detailed explanation of this code. So that's what you need to know. So if you are interested to get the details of this particular data and a detailed explanation of these codes, you can just watch that video as specified. So I just know that. So let's proceed. So as part of the exploration, it's also important to do some subsets. Okay, so we do some subsets to get the columns of interest. Those are the data sets you will use for the machine learning activity. So that is what this does for us. So here we look at subsetting and then getting the columns that we want. So the columns are here, and then we want some of them. We want from 16 to the last column. So 16 up to this one here. So we are looking at this one here up to this one here. That is what we need for the classification tags. So that is what this code does for us. So let's do the subsets and then we can proceed. So subset has been done. So let's check the shape of the subsets. So run this code and then you get the shape. So we have 2207 and then 18. So notice that the number of columns has now been reduced from 34. Yeah, I think it's 34. From what we did here, it's 34 to 18 because we are using just these columns for the exercise. Again, we can check the information here, subset.info, to get what we want. Okay, so let's proceed. So let's continue. As part of data exploration, it is important to check the missing values of your columns and the rows. Missing values can result in a poor performance of the model, so it is important to identify which columns or which rows have missing values. So this command here will check the columns that we have here and then check how many rows for each of these columns have missing values. So let's run this. Okay, so we have the sum here that tells us the number of missing values. So if you check the columns here, we have 0, 0. Those with 0 means there are no missing values. Those with values greater than 1 means they have missing values. So here, if you check this column here, there are 3 rows with missing values, or let's say 3 cells under that column. So you can check that some of these columns here have missing values, and that is what we have here. So if you have missing values, you need to deal with it. You need to handle it. And so one way of handling missing values is to remove all rows or columns with missing values. For this tutorial, I am going to remove all rows with missing values. So that is what this code will do here for us. So let's run this. And then once you've done that, you can also check the shape to see how many samples we have now. So notice the number of samples has reduced, or the number of rows. Formerly it was 2207, but now it's 2156 because those rows that have been removed had missing values. So at least now we are still cleaning the data, so it's important. So this is also part of cleaning, just to make sure your data is in the correct formats and states for the machine learning tasks. Let's check the columns again. So now we have the columns here. So as you are processing your data, it's important to also do some of these queries just to make sure that you have your expected output. So I just take note of that. So these are the columns. Now with this data set here, it was a data set on malaria. So the column here is for the class or the malaria outcomes. This column here is for that. So this column is the class or labels, if you also call it that way. So that is what we have. The others are features or variables or measurements. So let's check the outcomes or the malaria types we have in this data. So this will let us know how many classes we are dealing with. So let's run this. The code is here. Let's check. So let's do it this way. Okay, so if you run it, you see that we have 3 entries here. So these are the classes. And so because the number of classes is greater than 2, we are dealing with a multi-class problem. And that is why we are doing this tutorial, so that I show you how to plot ROC curves for a multi-class model. So let's proceed. There are ways to check the classes. There's another approach you can use to also check, but it depends on what you want at the end of the day. So this will give you everything here. So we have these 3 here, and then these are the entire classes or labels. So that's it. Let's do a head to just check the first 5 entries or first 5 rows for the subsets. So the subset is what we are going to use for this exercise because that is the data we need. So we have it here. when doing machine learning, it is important to also check the class distribution. How many samples belong to a particular class? It's important. So this will tell us, this command here will tell us the numbers for each class. We are dealing with 3 classes here. So these are the numbers. So we have non-malaria infection, uncomplicated malaria, severe malaria. So we have their respective count here. So with this information here, we can also visualize it. Visualization helps us to better understand the data and helps us to do comparison. Okay, so it helps us to do a quick comparison, and then we can use that to inform our decision on what to do next. So let's plot these values here in a bar plot. So this code here will do it for us. Okay, so we have the bar plot here. So if you check this and if you check this, it's easy to compare and then interpret this one here. As the saying goes, a picture is worth 1,000 words. So this here lets us know the differences. So with this data set here and looking at the numbers, I will say that there is a class imbalance here, because if you check this one here, this class here, and then if you check this one here, this like almost twice this. Okay, so there's a class imbalance. So class imbalance is something you also have to watch out for when dealing with machine learning. There are models that have been designed to work on imbalances, data imbalance. So you need to look at the models and then look at which of them work best for a particular situation or scenario. You can also correct or account for this class imbalance by doing oversampling or undersampling or other activities or techniques. So you need to decide what you want to do and then apply the appropriate methods for it. So these things are all stuff that you do as part of the exploration and then cleaning. So it's important to take note of that. So you can also look at statistics just to get some information about the data. And so we have some statistics here to tell us the mean and then standard deviation, and then we have all this information here, which I'm going to skip them because the focus is to just get the ROC curves. But these are things you do as part of the machine learning task, because these are things that will help you to achieve your overall goal and to help you to interpret your model and interpret the data. So make sure you do all these things first. You can also check correlation. So this code here will check correlation for us for the features. So when you have correlation, then it can help you to identify redundant features and remove them. So it's important to also check these things. So you can also visualize the correlation matrix using a heat map like this. And so here it's easy to visualize and look at which features are highly correlated or which features have low correlation. And so when you are looking at correlation, you can decide to remove one of the features which are highly correlated, but those things you have to decide whether you want to remove them or keep them. But these are things we will discuss in a later tutorial. So just know that correlation can also be used for removing features or for feature selection. So let's proceed. So after exploration and cleaning, it's important to also do pre-processing. So pre-processing, or let me say data pre-processing, helps you to format your data and put them in the correct shape and format so that you can feed or pass data to the machine learning model. So that's what we are going to do. So let's check this. I think we have some cells hidden here. Let's check. These are the cells. So the first thing we'll do under data pre-processing is to separate the labels from the features. So that is what this does here. So the X here is for the features themselves, and then the Y is for the class or the label. So if you check the table here, let's go back. So we have these are the column. Let's just check the subset here. So all these ones are the features. So those ones will be subsets, and then we have this to be the class. So that is what this query is doing, just to get it for us. let's scroll down to check it. So here we are subsetting all rows, and then we check from the first column up to the end. And those are the features, and then the 0 or the first column here is a class. So that is what this does for us. So we are using pandas to do that. So let's run this code. So this will do that job for us. Okay, great. We've done it, but you can also just confirm by looking at the shape. Okay, x.shape, y.shape, just to make sure that you have the same number of rows. So you can run this code and make sure that we have the same number of rows. So we have 2156, 2156. So we are on the right track. Here is 17 because we want just the features. And here is one column because we are dealing with just the class or the label. So that is what we have here. So now let's proceed. Okay, so let's move on to the next stage, and that is encoding of the labels. Here we encode the labels because they are categorical data. If you look at the labels here, or the classes, let's scroll up. These are the labels or the classes. So these are categorical data. So we need to encode them. Okay, so we are encoding them so that we get them to be represented by integer values. So that is what this encoding will do for us. So we are using some libraries here, scikit-learn, to help us do this. So we have the label encoder to help us do the encoding. So let's run this to get the encoding done for us. So that has been done. So after encoding, we also need to split our data. So we need to split the data into training and test sets. So training sets will be used initially, and that will be used by the model to learn and identify patterns that can be used to make future predictions. The test subsets will be used after training for evaluating the model. So let's do the splitting with scikit-learn. So we have the train test split here to help us do the splitting. So let's run this. So we are using a ratio of 80-20. So that means 80% of the data for training and then 20% for testing. That is what this is doing for us. So we have it done. So here you can also check, let's just check here. Let's input, let's say xtrain.shape. Let's run this to get the shape. Okay, so we have the shape. So there's the training sets. You can also check the xtest.shape just to get the number of training and then test subsets. So that is what we have here. Okay, so these are the numbers. Now, once we are done splitting, it's also important to also make sure that the values you have are normalized. Now, we do normalization so that we have all our values within a particular range, within the same range. Now, if you go back to the describe command, we have these values here. If you check the minimum and maximum for each of these features, you realize they are different. Okay, so they are in different ranges. Okay, they are in different range of values. So this can affect the model's performance and can lead to bias, meaning that the model might think some features contribute higher or they are much important than other features, but it might not be so. It may be that because the values are different and they are in different ranges, that is what the model is using to make that decision, but that may not be correct. So to account and to correct for this, we normalize the data so that they are within the same range, and that will help the models to do an easy comparison and give us an unbiased output. So this can also help us to interpret our model better. So let's proceed. So that's what we are going to do here. So we are going to normalize the data by scaling them between the values of 0 and then 1. So that is what this will do for us. So there's also a scikit-learn method here that will help us to scale the data into between 0 and then 1. So let's run this. So run this to get it done. And please know that we are scaling just the features, not the class, not the outputs, not the labels, just the class. So notice we are filling with just the x here. These are the features or the variables. So let's just check the values here. I'm just looking at the values for the normalized training sets, just checking one of them, and then just checking for the normalized value for the original data, which is here. So notice the original data was here 10.9 and it has been scaled. So it's now 0.19, which is between 0 and then 1. So this is how the transformation is done. So it's just for you to compare and then check. Okay, so we proceed. So now we have everything we need. We have done the exploration, we've done cleaning, we've done pre-processing. So it is important that you do all these things. And now it's time for the classification. So with classification, what we want to achieve at the end of the day is to get our model to be able to make predictions for us, is to be able to get our model to classify our data into the various classes of our interest. So let's first import our models. So I have one versus rest classifier, random forest classifier, ROC curve, and AUC. Now with classification, we have two phases. We have the training phase and we also have the evaluation phase. We will start with the training phase. So with the training phase, we feed the model with the training data. This is to help the model to learn and identify patterns, and the patterns identified can be used to make future predictions. So that is what we are doing here. So let's open this cell and then continue. We are using the random forest classifier, and so I have it here. And this is a parameter that can be changed. Okay, so you can always modify and then look at what works best for you. And we also have one versus rest classifier here. This is the core parts of this tutorial. Okay, ROC curves by their design are meant for binary problems or binary classification tasks. And so a strategy that is used to extend ROC curves for multiclass problems is to use the one versus rest classifier. So with one versus rest classifier, what it does is that it pits one class against the other classes. Okay, so it's kinds of break a multiclass problem into sub-problems which are binary in nature. So let's say we have three classes here. What one versus rest classifier will do is that it will pit class A against B and C. It will pit B against A and C, and it will also pit C against A and then B. And so you can see that we have a binary structure here. Okay, so that is where the name comes from, one versus rest. That is what we are doing here. Okay, so we have it here. So we run this code and we also let the model do its predictions here. And then we also generate probabilities here. We are going to use the probabilities as well. So let's run this code. Okay, so we have run the code. So it's time for the evaluation. And this is where the ROC curves come in. So let's proceed. Okay, so the ROC curves here differ slightly. The code for the ROC curves differ slightly, okay, from the one used for binary classification. And so I will just explain the important parts here. This is the first part I want you to take a look at. So here, what I do is that I binarize the outputs, the predicted classes here. Okay, it's important to do this because the probability generated here are done for each class. And so we have, let me just show you here. So you can also do same. If you check the probabilities here, if you check the shape you will see that we have 3 here. Okay, so this 3 here is representing the number of classes. So each class will have its probability. Okay, its probabilities generated. And so we need to properly format our Y labels, our predicted Y labels, which is here, so that it also has the same shape as this. And that is why we bannerize it here. So take note of that. And so once we bannerize it, we are able to get each class and then also get its corresponding probabilities here and then use that for the ROC curves. That is what I will say for now. Okay, so that's what we need to know. Let me just show you something else here. If you check the predictions, the shape, let's check it here. You will see that the shape is what? The number of rows is 432 and then the column here is just 1. Okay, but we have to get it into this shape, and that is why we bannerize it here to do that. So that's what you need to know. And then after that, we iterate, and then for each of the classes, we get its predictions and then its probabilities, and then we generate the curve and then the AUC value. That is what this code is doing for us. And I also give a label here. So let's run this code. Okay, so the code has been executed. So if you scroll down, you will see the ROC curve here. So curves are generated for each class, and that is why we have 3 curves here. So the color codes here will help you to identify the curves for each of the classes. And there is also the AUC value here for each of the classes. So if you look at the AUC values, you see that this particular binary situation, severe malaria versus rest, the model does a good job in distinguishing between severe malaria against the rest of the classes. So here we have a good score here. This is followed by non-malaria versus rest. So again, the model does a good job in distinguishing or separating this from this here, from the rest. Okay, where the rest here refers to severe malaria and uncomplicated. And then we also have the model doing fairly well in separating uncomplicated malaria from the rest of the classes, which in this case becomes severe malaria and non-malaria infection. So this is how ROC curves for multiclass work. Okay, so you can also use the steepness to get an idea of the model's performance for the classes. So here you can see that the best performing one is this one here, severe malaria versus rest, and you can see the steepness here as well. You can also check same and then get the performance for these classes. So that is how it is. So once again, we come to the end of this tutorial, and I believe you have learned a lot. And if you also want me to do other tutorials, when I say other tutorials, if you want me to do tutorials on how to generate ROC curves for other classifiers, other machine learning classifiers, you can also put it in the comment section. I'll try and get something up for you. If you also want to support this channel, there's a buy me a coffee link in the description box. You can use that to buy me a coffee as well. Lastly, you can download by right-clicking the figure and then going to save images to save the image as well. You can also download the notebook. Just come to File, Download, and then just download the notebook here on the .py format. So just go and then download it and then learn it. So that will be all for this tutorial. Thanks for watching, and I'll see you in the next session. Goodbye.